This NPN only. Let me show for NPN only. Yeah. Okay, there's a collector, base, this emitter, and we'll first we'll construct it. So base emitter junction. Where is the base emitter junction? This one, base emitter. There's a base emitter junction. So it should be forward bias, no? So for that, I'll bring a cell. And this is VBB. I'll write it. This is RB. Why the cell is connected? Because P type connected to positive terminal, N type that one. What is the basic core idea? Base emitter junction, forward bias. Collector base junction should be reverse bias. Similarly, I should reverse bias this junction. So this N type should be connected to the P type of a cell. And there's a her thing. Huh? Common, no? I'll just call this a thing, this one. So this is VCC, this RC. Okay, no, why the cells like this? This is the reason. Now to measure this current, I'll bring one microampere. To measure this current here, I'll bring one milliampere. So what it will measure? Collector current. What this will measure? The base current. So how the current should flow? How to predict the direction of flow of current? So look at this. There's a NPN transistor. So I'll give the circuit diagram. I'm showing both so that will be easy for you. This is a collector, base, this is emitter. Look at arrow. You can show arrow here also, need not be there only, this arrow. Okay, how the circuit construction will be. So this is the, to measure current, microammeter. If you can understand this very easier, the initial diagram is little bit very difficult for you. Once you catch this, rest all very easy, you can manage. There's a milliampere. You should not scold me that, sir, what you did, because you go to the BTech, no, for 3 years you're going to learn. Here I'm going to wind up within 3 hours. I'll try my level best to at least impart the concept. Okay, look at now direction of current, how to show this. IE will be in this direction. No? Look at the arrow, is an NPN transistor. Then IC must come like this. Then IB should come like this. This is RB. This is VBB. This is VCC. To measure base emitter voltage, I'll bring one voltmeter, VB. To measure collector emitter voltage, I'll bring one voltmeter, that is VC. And these are variable. I'm going to vary the voltage. I'm bringing some different circuit. In books what happened, they didn't bring this variable one. All the circuit will become very complex. That's why I'm just simplifying in this way. Because now if you go to the lab, no, we have a variable voltage source. If you go back to 1970s, 60s or 50s, no, we didn't have variable voltage source, a fixed voltage. By using resistor, we used to, but I don't think so. Even rheostat we don't use in lab. We use circuit of this kind only. So let me stick on to the modern circuit. What is the duty of this? What this, it will measure base current. Measures base current. Or this, measures collector current. There's a duty of that meters, ammeter it is. This is a voltmeter, measures base emitter voltage. Measures collector emitter voltage. I want to study that how current and voltage will vary. Means how these are related. Say what is the thing? How input voltage, input current are related. Means I'm interested in this one. How this VBE, this is the input voltage, this is the input current. This is called like an input section. So what are input terminals? Base and emitter. What are output terminals? Collector and emitter. Which is common? The emitter is common, no? Therefore it's called as a common emitter configuration. Common emitter, common. That emitter is common for both for as well as base and emitter. Therefore it's called the common emitter. And this is called like input. What all? This is called like an input section. What all that audio signal which has to be amplified now, I'm going to supply here in this region. And what all that output signal which I got now, I'm going to collect from here. So this called like a input, this called like a output section. Good to understand the basic diagram. Okay, now you need not to bother, sir. I don't know anything about transistor. Good, nothing to do because you know KCL, KVL, that is enough. First apply KCL, what you can write. IC plus IB should be equal to IE. I think that's already you know. Then next after this, what you should know? You should know how to apply KVL. I think you can very easily write KVL looking at this. I'm now trying to generate you the idea. Let's write the loop equation. So here base emitter voltage will be there, no? VB. Okay, write the loop equation. So there are say, shall I say no? There are three important things are there. What is applying KCL? IC plus IB equal to IE. I'm trying to generate now problem solving skills. Let me have water. You just make observation. I'll have water. If you understand this transistor and if you're able to do problem, I'll consider myself a good teacher. Not best, maybe I say I'm a good teacher. Because at this level in less time, if I'm able to make you think and understand, do numerical, I'll consider myself a good teacher. I feel that, okay, I'm doing justification to my job. So you do one thing, you learn this transfer. Today, I think this week, Semiconductors will discuss, no? You'll be having so many engineering colleges in Hyderabad. BTech in electronic and communication, especially target those students who are in fifth, third, fourth, fifth sem. You are going to ask them to explain in that college out of so like say 100 students are there. Even if two students are out, so like even if five students, if they are able to explain, okay, then you can say okay, it's a good college or student isn't good. Otherwise, what happened? Gone. There's a very sad state. You just go and ask the BTech student. They should know all this. Huh? The moment you give circuit, they should write KCL, KVL. They hardly know how to write KCL. KVL, finish over. So forget about understanding concepts here. So what after this Sunday, what you get the knowledge, no? You go and if you want, you can test it. You'll be having some relative, somebody, just ask them. If you ask any IITN or NITs, they will answer. But other than that, Indian colleges, nobody will answer. I literally tested. Past 20 years, I tested. So just to imagine what they're doing in that college, God only knows. Without learning transfer for 5 years, for every application, this will be there. Without, if you don't know how it works, then how you learn the application? So what happens in college, like what happens in happy days? All of you, I think some 1 month back, no, my wife told, okay, it's a very good movie. You can watch related to students. I thought, okay, some any fine, something related to engineering student. Okay, let's watch. I think it's an old movie, no? I don't watch movies. So after watching Happy Days, then what is the conclusion? College is not marriage bureau, no, where you are going to get life partner. College is something where you are going to acquire the skills needed the whole life. And what was the projection of that movie? And my wife told she that it's a super hit movie. My wife and we don't go to any theater. Anything comes in television, we watch it. And she told it's a super hit movie. Okay, fine. I was waiting for conclusion. What happened? What happened? There's no engineer involved in that movie, no, and it's all based on engineer and everything about the romance. What only like you go to engineer college to get life partner. This and everyone liked it. Later on, I asked some here and there, here and there. Okay, it's a good movie and good movie. I think my neighbors are the few engineering student. Happy days, sir, it's a good movie, sir. You watch it. This is a thing. How you'll get a job? Tell me what you do. So there's a thing. I'm not against anything, but something, like what is meant. The institution is meant to acquire the knowledge, no, and that itself we are losing it. It's a very sad state of affair. Huh? Like I'm really, so whenever I get some time, no, like vacations, no, I do visit some colleges here and there. That one, the what level things are going on, what actually going on. Things are very pathetic. Huh? If they made a movie, means you just imagine. So please come out of the fantasy world, be realistic world. That one. Hmm? So it's not that, see, in that college, it's not that you can't acquire knowledge. Just go open book, start reading, you'll get knowledge. But nobody does. So we should not blame any college. Huh? It's all our mindset. So by bad luck, even if you enter a college, no, see that your aim should be what, to acquire knowledge, huh? Not to enjoy. Enjoy what is there. You can enjoy. Watch every week one movie. Nothing wrong. Play cricket, play games, go for trip. But you should acquire knowledge. That itself gone, then gone. No? Please, I'm very particular about this particular thing. So somebody calls for some functions here and there, especially in colleges. No, I'll not attend. I'll get irritated. Like it's not something. No, you call me for any science exhibition, something we did project, come and watch. Okay, good, but not for some functions. No, annual function. Okay, for 10 days you prepare. So they have become places of enjoyment. Very sad to say. Even IITs are slowly turning up. I don't know, like in Chennai IIT, they called this for New Year. They called, they invited a guest. You know who is, like some comedian, Brahmanandam. You are the chief guest. He's skilled in his own. But what to do with Brahmanandam there in IITs? You don't get any scientist or some very good engineer working in so many multinational companies who are doing research something. So you didn't get, you invite such people. Okay, Brahmanam invited to some film function. Okay, good. What to do Brahmanam with IIT? I don't know. Like This is something I am not against anybody, but our mindset is such a way that we are got diverted. Even IITs know the quality has come down. You check it, the research materials, no, all it has come down. The students are not showing interest in the research attitude. So again, they are getting deviated more towards what enjoyment in life. So the same student when he goes to the abroad university, things are different. So the environment here in things are like that. Huh? So lot of things are there for you. You have to take care, because I think I know some information I've just shared with you. So I'm not against romance, because I also married, have family. I do like my wife. It's not that I'm sannyasi here, talking like this. So what has to be given priority at what place? Some that is very important. Okay, let's come for this. Okay, all of you. Now we don't know anything. We don't know what it is. Shall we write KCL? Shall we write KCL? Yes. What is KCL? IE equal to IB plus IC. Shall we write KVL here? Or looking at KVL. This is a forward bias base emitter junction. Plus VBB minus IBRB. Keeping numericals in the mind, I'm generating now only rather than finding a numerical. Minus here, what is the voltage potential difference? This will be plus, or the polarity, or this like a voltmeter, no? Go around like this. Or if you find this difficult, go around like this. Here, what you encounter? You encounter one cell, no? Can you remember? VBE, we have to replace with 0.7. That minus VB. If any forward resistance are there, if any resistance is there, if they give RF, that also you bring it RF. Okay, let me just stop it here. This over input section. Now come for output section. At output section. Right now the plus VCC. Okay, yeah. There's a loop. Plus VCC minus ICRC. Sir, this emitter ideal. It's ideal. I'm putting short circuit. Sir, emitter having internal resistance 2 ohm. Right, IC into 2 ohm. Go back to current intensity. Here I'm taking the meters are ideal. Got it? No, I'll come like this. No, so this should be the positive polarity. So minus VC equal to 0. Okay, plus VCC minus no, plus VCC minus ICRC minus VC equal to 0. So this is the loop equation. VCC minus ICRC minus VC equal to 0. I think your chapter is over. Rest I'll explain some concept. You can pick up any numerical and do it. What is VC? Drop across collector emitter. Agree this one? Okay, let's get into our theoretical ideas now. I want to study this, how VBB means how this IB and VB are related. How this IB and VB and these voltmeters, I'll show it here. No, let's come to this one. Means what is input characteristics? How this input voltage and input current are, these are not input voltage, these are biasing circuits. These are the input current, this is input output, this output current, output voltage. Input current, input voltage. In this one, so what is input current here? IB. What is output current? Is IC. Now what is the input voltage? Is VB. What is output voltage? VC. These are some terms, because I say input voltage, input current means it should flash for you.